Okay, so we got questions here that we want to answer. A couple of questions. Where are all three functions positive? Where are all three functions negative? Okay? Well, before we can answer that, it's clear that people still need a little bit of preparation to answer the question. So I asked, where are all three positive? And somebody said, when x is negative. Okay? And I said, well, okay, if x is here at this marked point, are they all positive? Well, still, not everybody looked like they were sure of the answer. Some people did. Yeah, about half and half. Okay, well, if x is here, is f positive? No. F, when x takes this value, the point on the graph corresponding to this x value is here, and y is clearly negative, right? Remember, it's y equals f of x. Y is the value of x, so the value of x is the y coordinate. The y coordinate, when you have this x coordinate, is negative, right? Now, for these functions, well, the y coordinate of this function is positive, and if these are straight line functions, this extends a little bit, and it'll be positive, right? So now we have two positives and a negative. If we talk about the function, remember on the homework, we have the k of x function, f of x times g of x times h of x. Okay? That k of x function is the product of these three functions. So for any x value, we get the k value of k by multiplying the 3, right? If this is the x value, whatever it is, what can we say about k of x? It's going to be negative, right? Because f is negative, g is positive, and h is positive. Okay? Make sense? Okay. Where could I locate an x value that makes all three functions positive? Can you give me a value of x on the scale that we've...
Negative 20.
Negative 20? Okay, if x is negative 20, what's the value of f of x? 0. Okay? So that's a good point to have chosen because I can make a point with that, but 0 isn't positive. 0 is just 0. But let's discuss that. Okay? So x is negative 20 makes f of x 0, as we determined here, right? So what's the value of k of x? Positive, negative? Not positive, not negative? Well, if it's not positive, not negative, what the heck is it?
0.
0. Because f of x is 0, and you're multiplying that by this and this, right? If you multiply by 0, you're going to get 0. Always. Okay, so if x is 0, is negative 20, f of x is 0, and k of x is 0, right? So we just discovered a point where k of x is 0. We got a value. K of x is 0. Whatever the value of k of x looks like, it's got to go through the x-axis here, doesn't it? Okay? Now, can you give me, that was a good try, but can you give me another try at a number that makes all three positive?
How about when g and h is negative, so when you multiply it, the two negatives will cancel out, and the
Okay.
f will stay positive.
So what would the value be where that occurs?
Probably in the middle of them?
Can you give me a number that you know would give me a negative values of g and h, but positive value of f?
Negative 2.
Negative what?
2.
Negative 2? Okay.
Is it just in between the negative
Well,
20?
let's see. Now, negative 2 is a good answer to my first question. And that might be what you're thinking.
How about
Okay?
10?
Because you might be, and we'll hold off on your answer in a minute because that's a very good observation. Okay? Now, what my original question was a value that makes all three of them positive, right? Okay, if x is negative 2, that'd be somewhere around here, right? And looks like this one's positive and this one's positive. It looks like the two of them are almost equal, but we certainly have three positives, don't we? Okay, so if we have a point anywhere around here, it's clear that all three are going to be positive, right? Okay? Now, Elena hypothesized that there might be points where two of them are negative and the other is positive. Can you tell me where a point might be where two are negative but the third one is positive?
23.
Again?
23.
23 would do it. Anything to the right of 22, anywhere to the right of here, these two are both negative, right? So if I take a point here, G is negative, H is negative, but clearly, you know, if you extend this, it's going to be about here, it's going to be a positive, a pretty big number, right? So you'll have two negatives and a positive, okay? Is there any point where you have one negative and two positives?
What's that negative 20?
I'm sorry?
Anywhere this side of negative 20?
Anywhere on this side of negative 20, right? Because to the left of negative 20, clearly F is always negative, and these two are going up, so they're positive, right? I mean, they're already positive at negative 20, and they're increasing as you go to the left. Okay? Does that make sense? So, okay, is there any point where all three are positive? I mean, there are. Where would that occur? Can you give me an interval that encompasses all points where all three are positive? 5. 5's not an interval. 5 is a number, but yeah, 5 is real important to that interval. What else?
Between like negative 19.9
Well,
to...
the open interval from negative 20 to 5.
Yeah.
Right? Everywhere between negative 20 and 5, all three functions are positive. It's clear from looking at the graph, right? And you can also see it by looking at this. Where's G positive from negative infinity to 22, right? Where's H positive? Negative infinity to negative 5, right? If they're both positive, then, well, they're both positive from negative infinity to 5, right? From 5 to 22, not so, because between 5 and infinity, H is negative. Okay? Now we can write that out more formally with intersections and unions, which I hope you remember something about. But it should be clear that if G is positive from negative infinity to 22 and H is positive from negative infinity to 5, and G isn't positive, I'm sorry, H isn't positive past 5, that they're both positive only between negative infinity and 5, right? Then you put that together with the fact that F is only positive from, I wrote this wrong incidentally, this is negative 20 to infinity, right? I didn't put the negative in there, okay? So from negative 20 to infinity, F is positive, then you don't get to go from negative infinity to 5, you only get to go from negative 20 to 5, right? And you can see that on the graph, okay? Now you can just look at the graph, of course, and see that between here and here they're all positive, right? Okay? And that's another good way to look at it. But you want to see it all ways. So, one way or another, they're all positive on the interval negative 25. Open interval. Doesn't include negative 20 because that's a parenthesis, not a bracket. Okay? Doesn't include 5 because that's a parenthesis and not a bracket. Understand? Okay, how about all negative? Well, we can reason it out pretty easily. F is negative only from here to here, and the other two are positive, right? If F is negative, then both G and H are positive, aren't they? Okay? Okay. Two more questions. Two positive, one negative. Where are two positive, one negative? We use intervals, right? In interval notation, where is it that you have two positives and one negative? And where is it that you have two negatives and one positive?